Okay, we're continuing on with the vocab and familiarizing ourselves with angles and getting comfortable with that. So it's going to make life easy as we're moving on to trig. So another little vocab here we have is coterminal angles. Two angles in standard position. Remember what standard positions, break this down a little bit. Two angles in standard position. Where angles where the vertex is, or where the vertex of the angle is at the origin and the initial side extended to the x-axis. All right. Well, a coterminal angle, two angles in standard position that have the same terminal side are coterminal angles. So if I make an angle measure here, it looks like, well, we'll call it 40 degrees. An angle that's coterminal with a measure of 40 degrees would be if I were to make another angle that would go around 360 degrees and then plus another 40. That angle measure is actually 400 degrees. It's a 400 degree angle measure. So 400 and 40 are coterminal angles. In the same sense, if I were to go the other way around this way, negative 320 degrees would be a coterminal angle as well. Okay. Here's a theorem right here. If alpha, or A, is a degree measure of an angle, then all angles of the form alpha, or angle, or A, plus 360k. So this k up here means we can multiply by 360 by anything. So 360 times 1, 2, 3, whatever, are coterminal with A. If beta is the radian measure of an angle, so we have a different one, except for talking about radians this time. To go in a full circle for radians, we go 2 pi. Or if we wanted to, it has 2k pi, so we could go, well, say we plug 2 in for k, we could go around 4 pi. Or if we plug 3 in, 6 pi. See what I mean? We could just keep going in circles. Those are all coterminal with the angle beta. So here's an example right here. Here we're dealing with radians. Find one positive angle and one negative angle that are coterminal with an angle having the measure of 11 pi over 4. Well, we know if we go 11 pi over 4, we can add it. We can go in a complete circle, and that's going to be a coterminal angle as well. So we could add 2 pi to it. All right, adding 2 pi, just like adding fractions, we'll get a common denominator of 4. Make this an 8. So we'll actually add 8 pi. So 19 pi over 4 would be coterminal to 11 pi over 4. So it's just going around in a circle. All right. If we wanted to find negative one, well, we could go around in a circle the other way. We could subtract 2 pi. So if I start with 11 pi over 4 and subtract 2 pi, because that would be going around in a circle in a clockwise manner. Okay. If I subtracted 2 pi, we'll get ourselves a common denominator, which would be 4, and this would be 8. We'd get 3 pi over 4 when we subtract. Well, that's not a negative one just yet. But, however, we can go another 2 pi around. So, let's take 3 pi over 4 and subtract 2 pi again. Get our common denominator of 4, and this becomes an 8. And subtract. So, negative 5 pi over 3 would be a coterminal angle with 11 pi over 4. All right, why did I put 3 over 4? Sorry, 11 pi over 4. Negative 11 pi over 4. Sorry about that. Okay. And the same says here we're going to go doing with degrees here. Find all angles that are coterminal with 60 degrees. Well, up in our theorem there, we said if we started at 60 degrees and we added 360 k times, those would all be coterminal. If we kept going in a circle. And if I went in a circle 1 time, so k would be 1. 360 plus 60 would be 420. 420 is coterminal. If I wanted to go in a circle 2 times, I'd have 720 plus 60, which would be 780. Okay? We can keep going on and on and on. But this equation right here tells us all angles that are coterminal with 60. In fact, we could plug negative 1 in for k and subtract 360 from 60 and get negative 300. That's coterminal with 60 degrees. Okay? Now, a reference angle. And reference angles we'll deal with quite a bit when it starts when we start talking about trig, so make sure you pay attention. All right. Reference angles are the acute angle, so they're always acute. An acute angle formed by the terminal side of the given angle and the x-axis. So it is always the angle between the angle and the x-axis. In this case, all right, our reference angle's here, and actually it's the actual angle. So say that's 30 degrees. That's also the reference angle. Where this comes into play is when we're talking about an angle that's an obtuse angle, such as, let's say, this angle here is 140 degrees. The angle 140 degrees is a reference angle. Its reference angle is 40 degrees because it says it's an acute angle from the terminal side, which this would be the terminal side, to the x-axis. So the reference angle is 40 degrees. You just go as close as close as you can to the x-axis. All right. If I were to go this way to the x-axis, that'd be 140 degrees. But if I come down this way, it's 40 degrees. Just 40 degrees between here. All right. That's the reference angle. As close as you can get to the x-axis. If we had an angle that was down here like this, our reference angle would just be this little part right here. Same thing if we had an angle that would come all the way over here. Okay, our reference angle would be right there. Okay. That what I just described is this reference angle rule that I sent you. If that doesn't make too much sense to you, don't worry about it. As long as you understand what I just said, you'll be just fine. Example 3, find the measure of the reference angle for each angle. So I want to find the reference angle, 5 pi over 4. If we think about where 5 pi over 4 is, we know that this is 0 or 2 pi. We know this is pi over 2. We know this is pi. And we know this is 3 pi over 2. That's how radians work out. All right. 5 pi over 4 is slightly bigger, so it's going to be here's its initial side. 5 pi over 4 is going to be bigger than pi. All right. What they're asking is for the reference angle. They're asking for the measure from our terminal side to the x-axis. So what's left over? So we went over, this is 5 pi over 4. How could we get back to just plain old pi? All right, plain old pi would be the same thing as 4 pi over 4. To get back to the x-axis, we would have to go back pi over 4. So the reference angle is pi over 4. Okay? Our next one, if we think about negative 13 pi over 3. Well, we're going to go in the negative direction. So we're going to go this way. A full circle would be 2 pi. In this case, since it's over 3, it'd be 6 pi over 3 would be a full circle. So if I want a full circle, we've already taken up 6 pi over 3. And what's left over is 7 pi over 3. Well, it looks like I can go another 6 pi all the way around. So it goes around twice. All right. So if I take another 6 pi away, I have pi over 3 left over. So I need to go a distance of pi over 3 here and draw my angle. My reference angle is the distance from my terminal side to the x-axis. So distance from my terminal side to the x-axis is here. We went down pi over 3 was left over. The last one here is C. Last one is C is 510 degrees. Okay, so 510 degrees. 510. Well, that's bigger than 360. 360, okay, so what's left from 510 and 360 is 150 degrees. 150 degrees is past 90, and it's not quite 180, so it's here. So that's 150 degrees from here to here. That's 150. If its reference angle is from the terminal side to the x-axis. It's an acute angle from the terminal side of the x-axis. What's left over is 30 degrees. Okay? I hope that made sense to you. What I want you to do, and you can pause it here, I've sent you these notes, is I want you and a partner, this is part of your assignment as well, I want you to fill out these 3 questions right here with a partner, and also work on your assignment here. Again, I've emailed these to you. Feel free to watch this as many times as you want in case you didn't get something. and have a good day.